Hello everyone, in today's video we're going to review together Java I/O APIs. As you already know, I/O here means input and output. More specifically, read from a resource into a Java application and write from a Java application out to a resource. A resource could be a disk, file system, or a network, etc. There are two main concepts in Java I/O. First, we need to know where the file is and its characteristics, like its name, it exists or not. It's a folder or file, blah blah. Then the second, we can read and write from to this file. But they are not here, that we will only focus on the first one this time. Another thing, basically in this video, we will base on the documentation here in Dev.Java to remind ourselves about Java I/O APIs. Dev.Java has a lot of good resources for Java developers that are well structured, are clear with code examples, and the most important thing is free. So thank you very much to guys who contribute to this page and make it available to us. So we can see the generic, lambda expression, annotation, exception, the stream API, and what we are focused today. There's a tutorial in the Java I/O API. So you can see a lot of tutorial here, right? Debugging Java. Okay, let's back to our Java I/O API. So this is the documentation for this video that we refer to. Okay, let's go ahead and back to our demo. As usual, we need to create a project by accessing start.spring.io. So even though we're going to play with Java only this time, not Spring, but personally I always prefer creating a project from here. It creates a folder structures and gets enough for me. Okay, so we'll name it Java I/O, and we're going to use the Java 21. And that's it. Let's download it, unzip and open it using your favorite IDE. I've already opened it in my IntelliJ here. Since we only play with Java, let's move on to the build operator and comment all the Spring related thing here. For example, Spring and dependencies. So we only play with plain Java, right? And maybe the Java application, I don't really need to the Spring Boot application, anything related to Spring. Okay, what we need to do next? Red meat. So, history. So basically, let's follow the documentation here. So basically, the Java I/Os was created in the mid-90s, the first version, and Java NIOs were released in 2002 until 2011 with Java 17. Java NIO was released. So let's back to our documentation. So we have mid-90s, so we have Java 1, right? And the Java I/O API was released, and the file class was introduced this time. So we can create an instance of file class using its constructor. So basically, they are all referred to the same location. And in 2002, we have Java 1.4 and Java I/O was released this time. Leveraged some improvements, and like URI last were introduced and being used in creating a file this time. So now we have a new way to create an instance of file using an URI. In 2011, we have Java 17 released, and by that we also have the Java NIO2. In Java NIO2, the path interface was introduced, and we can easily create a path object by using the path factory class. We have an S at the end, right? So it's a plural now. The second way to create an instance of path is by system default, the file system.getDefault, which is run under the path of get. So basically, we need to call file systems, get default, and get path. And the third thing is using the path.of factory method from path interface that were introduced in Java 9. Okay. Then let's copy all of them to make sure that we are referring to the same location. Okay. So we have file here. And this is the way to create a file from URI. And we have the way to create a file, actually a path here, from Java NIO2. And we have the second way to create using file system default. And then from Java 9 we have the factory method in the path interface. Okay, so if we take a look at the get method, we will see it's basically called off. And take a look at the off, then it's going to call the file system of get default of get path. So they technically refer to the same thing. Let's bring them out. So we have file 1, file 2, file 3, file 1, file 2, file 3, file 4, part 1, part 2, part 3, part 4, part 5, part 6, part 7, part 8. Okay, then let's run it. And then we will see that they all referred to the same location, even though this location haven't existed yet. So you see desktop.java.io, right? Desktop.java.io, but at the moment, okay, let's remove it. Don't even care. Delete. Okay, let's run again. Okay. So it's just a location, so we don't need this file is it yet. Okay, now we are going to compare the file and part in Java.io and Java NIO2. So which one should we use? So back to our README. Okay, so basically always refer using part in Java NIO2 whenever you can. There are some drawback of files listed here for the full list. Take a look at this one. So if you take a look at this, actually the same, right? So file was introduced in Java 1, right? So it represents the legacy way to access a file. And then they have a lot of drawback, like many methods of the file do not throw an exception when they fails. And the rename method doesn't work consistently. There's no real support. So basically you can take a look here. But yeah, we list down two of the reasons here is because we're going to confirm this one through our demos. So many methods of the file class do not throw exceptions when they fail, making it impossible to obtain a useful error message. The second thing is many of files methods do not scale. Requesting a large directory listing over a server can result in a hang. And a large directories can also cause memory resource problems, resulting in a denial of service. And these issues are fixed by using the path interface. If we're still working with legacy libraries that require file and its methods parameters, we can easily convert a path to a file, then pass this file to these methods, and then we cover them back from file to path to use in our application. In other words, we can use path in our application, and when we have to call a third-party library that requires files, then we then convert it to file and pass to these third-party libraries. Because technically both file path and URI are wrappers of a string, so we can easily convert between them. So for example, if we have a file 1 here, we can use file 1 to path to convert it to a path. We can have file 1 URI to URI to convert into URI. And if you have a path, then you have to file to convert path to file, path to URI here. And if you have a URI, for example, URI here, then you can use this basically path of get URI to convert it to a path, and you can new file URI to convert it into a file, right? So basically that's it. Okay, let's go ahead and move on to the most interesting part in this video, refactors files to part. For example, our application is written using a file, then we need to convert it to a part to get some performance benefit and another benefit, right? Then what should you do? Let's create this class. So let's copy it. Okay, so what we do in this class? So basically in this class we are going to, let's put a breakpoint here. So we are going to pass our location here. So the Java IO staging hi1.txt to our working with file. And then let's see what is going to behave. So basically this location doesn't exist yet, right? So we don't have the staging folder here. We only have Java.io folder here, but we don't have the staging folder, and we don't have the hi1.txt file. Then let's run this from step by step. So basically we can use the exit method in the file to check the file is exit or not. So in this case, since it doesn't exist, then we accept the if statement, and then we're going to get the parent by get parent file. So actually parent is the folder, right? The parent is now the folder, the staging folder, and we are calling the files.make directories to create a folder for us, and this one return a boolean. So if we successfully create a folder, then it's true, then we can move to. So we successfully create a staging folder, and then we going to create 100,000 files into this folder. So we are going to use the create new file. So basically after this we are going to have our staging. So let's reload from this. Then we have staging. So in staging we have now 100,000 files from hi1, hi0, hi1, and hi99999. Okay, and now our file become existed, right? Okay, let's move. So it's exit. Then we accept the if block, and then we're going to bring the name of our files, the hi1.txt. So we have hi1.txt. We can have the absolute path by calling get absolute path from file as well. We can have the is file to check is file or directory. Is file, so it's a file. It's not directory by its directories. And if it's a file, then we would like to get the last modified of the files, the length of the file, and this file is hidden or not, for example. Okay, and then we are going to refer to the staging folder by using get parent. So as you already noted that we use a lot of methods from file here, but only this one through IO exception. The others don't through any exception. So as we already state in the last section, in the README section, that so many methods in file do not throw exception, and we have an example of the delete. Okay, let's back to debug case here. So we have a delete. So delete also doesn't through the IO exception. It's only return the boolean. So we only know that it's successfully or failed, but we have no idea about why it's failed. So this time we're going to delete our folder, our staging folder, with 100,000 files in it. So it's failed with no reason. Actually, we cannot delete the folder that contains a file in it. But but if using delete, so we have no reason. And the next thing is now we are trying to delete the whole files in this staging folder, 100,000 files. And then this one also doesn't throw any exception as well. And then when all file deleted, of course we can run the delete again on the staging folder. And it should work this time. And then we're going to bring a attempt to delete the staging folder successfully. So basically, this is the flow of our application, of our class here. And then we would like to convert it by using the path. We are going a new class, let's say actions from path this time. And we are going to follow the mapping table in our depth of Java here as well to find a replacement for our method in File2Class. So basically, so this is our function on the files, and this the same function on the class. We are going to end up with this class. So see here, instead using a files, we're going to compare it. So from file, okay. So you can see here we have file exit, and in new part we're going to files exit part to create a folder. Instead of parent.make directory, we have the create directories parent. In order to get the referred to the child, we're going to use the parent of result. This one is the similar in using files, and then we're going to create this file. This one is similar one. Next, we are going to have the path of get file named, path of get absolute path, file dot is regular file, and files dot is directories. So they are corresponding to each other. We have File.lastModified, Files.length, Files is hidden. This is the same thing, but except that this method through exception. So if we take a look at the exception here, we're going to see it's going to throw the NIO exception and a security exception. So it's a runtime exception. Okay. And now we go into delete the folder with many files in it, right? So in the files, it's only return true or false with no region, but in a new API, in path API, the delete through a loss of exception, like no such file exception, directory not empty exception, IO exception, and security exception. This one is the runtime exception. Okay. Then based on that, we can behave on the exception that we receive. For example, in this time, we are going to receive a directory not empty exception, and then we can behave on that. So for example, we can bring out the reason why it's failed, because the folder is not empty, right? And for delete all of the files in the folder, so here we have the parent.listFiles. Parent is a file, Files.listFiles. So it's going to load the entire file. So this one is not performance method compared to the new DirectoryStream here in the new NIO2 API. And at the end, we're going to delete the staging folder, the empty staging folder, and it should successfully this time. Okay. Okay, let's run our action from path to see the same result. Basically run. Okay, we are going to create a staging folders and create 100,000 files, and this is file name, the absolute path. This is a file, it's not directory, it's the last modified, the size of the files is hidden, and we're going to delete the staging folder, but it's failed because the folder is not empty. And then when we delete all the files in the folders, so our last attempt to delete the staging folder again successfully. So we can confirm a lot of things here. So for example, many methods in the file do not throw an exception when they fail, and make making it impossible to obtain a useful method, right? So if you take a look at the example here, so in files we only have this try.create new file through exception, but if in a case of path we have create directories through exception, create a file through exception. We also have last modified through exception, side through exception, hidden through exception, of course delete one, new directory stream, and the last child here. Be aware this also being used with try with resources for the stream here. Okay, so the second confirmed that about the concrete example file.delete, and so for the files we have no reason why it's failed, but in part we can have several reasons that it will drop into these exceptions. Okay, and the last thing is that many of the files methods do not scale. Requesting a large directory listing over a server can result a hang. The large directory can also cause memory resource problems, resulting in a denial of service. So at the moment, we are currently running using full memory from my Mac. So that's why we don't see any problem. But okay, let's limit the memory by setting the maximum heap size of our GVM to 32 megabytes. Okay. So for example, okay, let's run it again using full memory from my Mac. So it's a file, right? Okay. This time, let's run it with the profiler. Okay. So we see the CPU time here for create file, create new files. Okay, delete file, and let's see the memory. So the memory is up to 127. How about path? So actually we won't see any clearly differences between two of them if we have a lot of memory. So this for the path. Okay, result. Okay, it's nearly 7 seconds. So this one is over 7 seconds a little bit, but they're not much different, right? Okay. And memory, 183, same. Don't really believe into the profiler here. I'm still not confident this is exactly or not, but yeah. Okay, let's limit our math heap. Okay, edit configuration. This one. Action from path, and I'm going to add the VM option. Light. Same thing from file. I'm going to add a VM option. VM option. Okay. Apply. Okay. Then let's load this one and run it again. Okay, from file, I'm going to run it again. The filer, but this time I'm going to specify result memory. How about the path one? File. Okay. Memory allocations. Yeah. Okay. But now let's string it a little bit more. For example, only give them 16 megabytes. 16 megabyte. I'm going to apply this one. File 16 megabyte. And okay. So in this one, let's run our file. Okay, and we can see that this time we are going to get the errors out of memory error. Java heap space fail relocation of Scala replace objects. So this method, because this method build up rate readme, because this method, like load the entire directory as one, so it's over our limit, then we have the out of memory error. And how about our path here? Okay, Refactor. Okay, so we see that if we are using the Java NIO2, then everything is perfectly fine without any problem. And if we take a look at the memory allocation, then we can see the memory allocation is now reduced a lot, right? Reduced a lot. And this time, if we are using the file of new directory stream to get the whole files in one directory, so it still works perfectly fine because stream is lazy load and it's loaded its element when needed. That's why even though we going to reduce our memory to even more slower, it still works perfectly fine. So that's why the new Java NIO2 is always referred, the path is always referred to use rather than files. So now we have 8 megabyte, right? And then let's run our path again. Path, so 8 megabyte, okay. And then we take a look at the memory. So 14 megabyte, so it still works perfectly fine. Okay, the last thing to remind you guys is about the directory stream here. The directory stream here returned by the new directory stream. So it is a stream and it's open and connection to the file system that must be closed. So if you are not using the try with resources statement, do not forget to close the stream in the finally block. So you see we are using files of new stream here. And then if you take a look at its documentation, you also notice that when not using with try lock resources, then the directory stream close method should be invoked after it was used, right? Here we are using the try lock resources, but if you're not using, then you have to find a lead and you have to close it. For example, stream.close, stream.close, something like that, right? Alright, well, that's pretty much just for this video. I hope you got something out of it. Thank you so much for taking your time for watching this video and the series. And as always, see you next time. Happy coding!